So hi everyone, welcome to the next in the Dalton seminar series. We've got a panel session today on the future of nuclear waste. So we've got our three panellists here in person, and we've got two more on Zoom as well to talk about the topic of nuclear waste now and also in the future. And we'll start with a bit of an introduction to our panellists, sort of overarching question, and then we'll go into just a bit of a Q&A, and you can obviously ask any questions you want of either individual panellists or in general. So to start with, I'll start with our panellists over on Zoom. So we've got Dr. Simon Norris, who's the Principal Research Manager at the Nuclear Waste Services and has also been working to implement the UK Geological Disposal Facility for higher activity waste. We've got Dr. Rick Short from the Nuclear Decommissioning Authority, who's also previously worked with NNL to support high-level waste vitrification plant. And then in person on our panel, we've got Dr. Mir Anamul, who's a EPSRC Early Careers Research Fellow, leading nuclear fuel and waste management research at the University of Huddersfield, particularly focusing on novel methods for plutonium and high-level nuclear waste containment. We've got Professor Kath, an academic within the Department of Earth Environmental Sciences, who's also the Dalton Nuclear Institute theme lead for nuclear environment and waste, as well as the Director of Radioactive Waste Management Research Support Office. And last but not least, we've got Tamás, who is a current PhD researcher at the University of Manchester and the Dalton Cumbrian facility, who is looking into the radiation tolerance of glass ceramic nuclear waste with high molybdenum content. So thank you all very much for coming. So we've got a sort of, to set things off, a bit of an overarching question, which is, what do you think are the key things we need to consider when looking at the future of nuclear waste within the UK or worldwide even as well? I don't know who wants to take the floor with that one.
Want me to start off?
Go for it.
Okay, so thank you for inviting me along. So you certainly asked us a big question to start with. And of course, I'm going to do the thing and tell you the information that I want to tell you. So I think the first thing I always think about when asking about this kind of key thing question is that the waste is already there. So we don't have an option but to deal with it. And the balance across that in terms of safety, environment and options for new nuclear is something that I suspect we might get into a little bit more today. And that the challenge for geological disposal of radioactive waste, which is the government policy, is going to be need a lot of different skill sets. So all the way from social scientists, geologists, chemists, material scientists, trying to include engineers, working together to deliver what is a significant national programme in the order of between 20 and 50 billion pounds worth of infrastructure to deliver this facility. And in the UK, we've got a system where we're thinking about a volunteer community, and that community volunteers to host, or those communities volunteer to host the geological disposal facility. And they have something called a test of acceptance, which means that over the years they develop a relationship with nuclear waste services, and they have to develop a forward programme and a forward platform of trust to decide whether opting to host this national facility for radioactive waste disposal is the right thing. But this is an achievable task. We've certainly got evidence internationally that, for example, Sweden and Finland are making good progress on a geological disposal facility. So to get to your question, they're the things I wanted to say. So what's the key thing that we need? I'm an academic through and through, so I'm going to say that we need to develop underpinning skills to support this significant programme.
Thank you for inviting me. I will expand a little bit on what you were saying. Possibly, perhaps I would first explain that when we talk about the nuclear waste in the UK and around the world, and the concept of geological disposal, we are mainly talking about the nuclear waste that is generated as a result of our civilian nuclear program that we have in the UK to generate electricity from it. And there's a little bit of defense waste that comes from the defense activity in the UK, where plutonium, for example, is being used for, well, was being used to develop plutonium-based nuclear weapons. And so we have ended up with a situation where we have a lot of plutonium that needs to be managed, and we have a lot of high activity waste that is as a result of the reprocessing of the nuclear fuel that was coming out of the nuclear reactors. And the geological disposal concept essentially addresses, is to address these concerns of high-level nuclear waste. There are other types of waste like low-level nuclear waste and intermediate level, but I think I will restrict myself mainly to the high-level nuclear waste and plutonium. And so in dealing with this, I think we have to keep in mind that sustainable future and ethical management of the nuclear waste must remain our key objectives, whether it's today or it's down the line. And that means protection of the human health, protection of the environment, protection beyond national borders. We have to deal with this problem within our national borders, and also because of the risks of proliferation, everything, it has to be dealt locally. And we shouldn't make any compromises with regards to get any economic benefits, because this is a key issue, and we can't jeopardize the safety of our generations and the future generations. Now, with that being said, we have the concept in the UK and around the world is there will be a deep geological repository where this nuclear waste will go. And we have been doing research on the subject for the last 30, 40 years. And so, for example, we were making nuclear waste, high-level nuclear waste canisters, which includes, for example, using glasses to contain this nuclear waste. And this research has been going for 30, 40 years, and we continue with the same process even today. So what is the benefit of doing the research that we have been doing from the last 20 years, or will continue to do in the decades to come, is essentially the concept remains same. It will be the GDF as long as the government policy is concerned, but we will try to build more confidence in the geological disposal concept. So with a better improvement in the science, we will better understand as to how this geological disposal will work, how the materials will perform, and to have a better risk assessment. So going down the line, we have to improve on our understanding of how this GDF will function, and the focus will be risk assessment so we can ensure the safety. Now, this is talking about essentially within the context of what the government in the UK has decided, which is the GDF. But there have been money. I will talk about a little bit about as what one might think of doing in the future. Now, some of the concepts may sound really ridiculous and perhaps are not accepted in the community, but because it's an open discussion, so we can all sort of throw it out and then discuss about it. Now, in the past, there have been ideas about space disposal. The concept was rather than doing disposal underground, why not send the nuclear waste to space? And the research was done on the subject, not extensively, mainly in the USA, where NASA did some research as to whether it was feasible to send the waste out to the space. And there were two main limitations of the concept. One was economic cost. To send anything out in the space, it costs a lot of money. And if we talk about, for example, managing plutonium in the UK or high-level waste, the rough estimate is about 10,000 pounds per kg of high-level waste, or per kg of plutonium. This is roughly how much it will cost to dispose it off underground. These figures will vary over because the GDF in the UK is not planned for until 2070. That's when we might have the actual GDF. We have to select the site yet, but the costs are estimated roughly around, let's say, 10,000 pounds. And when you talk about space disposal, so how much will that cost? Now, that used to cost in 90s about 30,000 pounds per kg. So it was very expensive. And then another was safety. You couldn't send waste out into the space because if there was an explosion or the rocket didn't perform, you will have the waste spreading up everywhere. And this was the risk. So going down, going into the future, we had to think about how the space travel and things like these, the rocket science, there is a lot of improvements in that. And the current costs per kg, for example, of transporting stuff to at least to the low Earth orbit is about 1,000 pounds per kg. So it's economically, it's not that expensive at the moment for, let's say, general stuff. But when you talk about the nuclear stuff, the things get more complicated, and it's not going to the low Earth orbit. If the idea of a space disposal was to be conceived, it will have to go to the high Earth orbit, and it's going to be very expensive. But down the line, the NASA has a plan of bringing down the cost of space transport to tens of pounds per kg, and we have to think about whether that will become a feasible solution. It's not currently an accepted solution in the community. This is one idea. Then in the future, there have been ideas about do we really need to dispose of, or can we think about transmutating this waste? The waste needs to go under geological disposal because it takes a lot of time for the waste to decay, and that's why we need to confine it to a space where it can stay for millions of years. But ideas have been ranging from using it in the nuclear waste and transmuted it to lower activity waste or smaller half-life time, or photo-induced fissions in the material of photo-induced transmutation. These are really the concepts which are in the very early phase and may not make economic sense, but as the new generations come, and they might probably come up with more radical ways of dealing with the stuff. And then we have to talk about the artificial intelligence. We didn't talk about artificial intelligence 20 years back, but with artificial intelligence, we can now probably explore more materials on the material science as to whether we can design more resilient materials that we have at the moment. And rather than focus on the engineered barrier, which is the geological disposal facility, we can directly talk about, can we build more and more resilient materials? So even if a GDF, the multiple barrier approach, if that fails, can we have a more resilient material that will survive underground? And so I have thrown up these ideas, but not all of them may make economic sense and perhaps are not accepted in the community. But we must be open to these ideas as new ways of thinking about things, the artificial intelligence, space travel, and space transport. These ideas come online, and we should be open to these ideas. And that's all. Thank you.
Thank you.
I will try to answer the question in relation to my position and the research area. As was mentioned earlier, I'm a PhD student working on radiation tolerance of high-level mixed materials. And I think that two main things which we should consider for the future of nuclear waste is good research communication and collaboration between industry and academic. Just let me explain the first one. So as it was mentioned earlier already, the vast majority of nuclear waste in the UK is currently held in storage facilities at or near ground level. But the long-term plan is to build these underground geological disposal facilities to store the waste for many thousands of years. And the way how the site of these geological disposal facilities will be determined is this voluntary approach, which means that it requires the public support. So it can be only built if it is supported by local community. So this is why I think it's essential for PhD students to learn how to communicate the research, the significance and the outcome of the research in a way that everyone can understand, even the public can understand it easily. It is essential because the term nuclear waste sounds scary for the first time. So I think it is essential to provide the routes for the public where they can access and understand the research that is undertaken for the safe disposal of the nuclear waste. And the other thing is collaboration between industry and academic. I think it is essential for the future of nuclear waste to train the next generation of UK researchers, us, with relevant skills and experiences that can be used in the industry later. And I think the best way to achieve this goal is to develop these collaborations between the academic and industry. For example, I'm in a very unique position because I'm part of a collaborative research consortium called Transcend, including 11 universities and 8 industrial partners. And being transfer students had a huge impact, a very positive impact on my field of research. So I'm more than happy to talk about in details later if you're interested in what it's like to be a transfer student. So it's very important for us PhD students, if there's an opportunity to collaborate, then grab the opportunity, because it's not beneficial only for us, but also for the nuclear industry, because the outcome will be a PhD thesis with better quality, but also a researcher with experience and skills in the software industry. So the two main things from my view is good research communication and collaboration in the industry and academia.
Thank you. Simon or Rick, do you have any further key points?
I'll come in, if that's okay. So I work for Nuclear Waste Services. We're responsible for enacting government policy as public servants. Policy is deep geological disposal of higher activity wastes. We have a United Kingdom radioactive waste inventory, which lists basically the waste that we are to manage and to dispose of. I think we need to accept that this inventory may flex over the years coming up, and we need to be have that in mind, be reactive to it, be able to react to it. For example, a new build will inevitably have an effect on the inventory that we need to dispose of. That could also have an effect on the messaging to communities, or the what the communities think of the process. I think also don't think of the inventory as ever growing. There are opportunities to look at waste treatment options, for example. So some of what we currently classify as waste, you may be able to treat it in a certain manner. Perhaps you can compartmentalize it such that some of the waste is can be treated and then can go to a near surface disposal facility rather than going deep, which would obviously save some money as well. And you know, so long as it is proven safe through various safety cases to do so. So I think there are options that we ought to think about sort of moving forward. So the baseline is deep geological disposal of waste in the UK radioactive waste inventory. I think we ought to be mindful of not excluding the possibility of some of that waste being treated, becoming, if you want to move it to a sort of lower activity waste, or indeed sometimes you could think about recycling some of it. So it's not a closed book. It's not the case that once it's in the inventory, it's always in the inventory. For deep geological disposal, there are possibly some other options and treatment options, which is a rich vein of future research, I would suggest as well. So we need to do research underpinning the efficacy of the deep geological disposal facility, but also research into, can we look at waste management, waste treatment options, such that what we finally do place in the geological disposal facility has been scrutinised, and where we can take alternative approaches but are still compliant with government policy, that we are able to do so. So there are ample opportunities to sort of broaden the scope. And I think that's one of the key reasons why Nuclear Waste Services was actually implemented. It's a collaboration of what was radioactive waste management and what was low-level waste repository limited. I think we will have options to other facets of work in relation to the nuclear cycle that we, in the UK, we weren't particularly active on before. Waste treatment and looking for alternatives to manage some of the waste, not all of it, some of the waste. I think will be on the cards. Again, I think the panel today is a good illustration of what we need. We need a good collaboration between industry, between supply chain, between academia, and working together. It's a very long-term project. We're looking at GDF closure well over 100 years in the future. It's many generations, many careers, and as well as making sure that we do our best technically, it's also, we need to make it an attractive career, an attractive employment opportunity. Make sure that we do get the staff coming in, get them in, keep them, give them interesting careers, and then hopefully that will help facilitate progression of the issue at hand. So thank you.
Thank you. Thank you. Rick, any?
Yeah, absolutely. I think, I mean, building on a lot of what Simon's just said and Kath touched on, and Tamás as well, the thing we need to consider is the fact that it's going to take a very long time to deal with the challenge that we've got at the moment, the existing challenge. Over that period of time, we're going to need a skilled workforce who understand the risks of the materials and the long-term effects and the consequences of the decisions that we're making in the near term. So this will be related to the techniques and the materials that we use for encapsulation of waste, the design and the functionality of the buildings that we might need to make for interim storage, and the way that those buildings and facilities will interact with the existing infrastructure, and the landscape and any future infrastructure that we might need to build around them to continue treating the waste that we've got at the moment. I think we also need to consider the fact that a lot of the people who are working on topics like plutonium disposition options or the GDF safety case at the moment, they're going to be retired by the time those decisions are enacted. So we need to make sure that we can retain their knowledge in a way that's accessible in the future and can be used to carry on the mission, you know, as we currently see it, and allow it to evolve as it inevitably will do. As we bring in new thinking and new innovations into the dealing with at the moment. A lot from the experience that we've had with Sellafield. We need to be confident that we're not making wrong, short-sighted decisions to solve a problem now, and potentially making the problem worse for ourselves in the future or for the future generations that are going to deal with this. And I think one of the key things as well that we all need to be mindful of, technical sort of scientific engineering community, is that there are political aspects to the work that we're doing as well. It's often obvious to us as scientists what the right course of action is and what the best way of treating a particular waste form might be, or the best way of disposing of that waste in the long term. But we have to bear in mind that we're not setting the policy, the government are setting the policy. And they have to take into account factors that aren't just about what is scientifically or technically the right thing to do. There are other factors that are influencing their decisions there. And we are operating in that landscape. We're operating in a landscape where we have to take into account the views of the community and effectively the electorate and the taxpayer at large, not just be considering what is the right technical option for some of these challenges. But broadly, I think long-term nature, the fact that, you know, if we stick to the current projected baseline, nobody who's in this meeting today is even going to be around by the time that the challenge is dealt with, if that's how you want to put it, by the time the mission is finished. So we have to be really mindful of making sure that knowledge that we're creating now is accessible for future generations.
No, thank you so much. Thank you all of our panelists for your comments on that. And yeah, I think especially obviously being in a room here with people doing PhDs or studying, and obviously a lot have links to industry as well. It's that collaboration and sharing research and making sure it's all passed down is a really, really key point. So thank you all. We'll sort of bridge over into the Q&A session for the rest of the sort of half an hour. So does anyone have any questions either within the room or over Zoom for our panelists? Yes, in the room.
Hang on, I wrote it down. How much will the recent licensing of the Finnish Onkalo repository and future operation of this and other repositories affect strategy on the UK GDF approach? But that is respecting that Finland's one currently isn't going to be dealing with anything like high level waste.
Sorry, could you repeat the question again, please?
So how will the licensing and commissioning and operation of the one I used was Finland's because that's the one that's closest to operation, but like any of them that are currently being built are going to come into commissioning, how do you expect that to affect the strategy for the UK's GDF, if any, you know, like as a case study, or for example, the learning that comes from that?
Yeah.
So we do, yeah, maybe I can start, maybe Simon can help me a little bit. So as I understand it, the Finnish repository is for high level waste. It's for spending for fuel. So it's into a particular type of geology. As we don't know what our site is, then I think what we can do is certainly learn so that we're not first of a kind to do this. Finland will be doing this. But we've talked about the different waste forms, and we've bandied phrases around like high level waste and intermediate level waste and near surface and so on. The UK's waste inventory is different to the Finnish waste inventory, and we're looking at a facility that will be co-disposed. So we'll have a high level waste that we talked about earlier, co-disposed with intermediate level waste chambers or vaults in the subsurface. So the complexity of the British system is going to be different, but I think even understanding that this is possible with a voluntarism system in a Western liberal democracy is a really positive forward benefit on the programme. How will it affect strategy? I think that the strategy has to be focused on both the scientific and technological implementation, the community engagement, and I guess from Rick's comment, the politics as well. So there won't be an immediate, oh, well, we're all going to change and do it this way. I think, you know, there are lots of things I could talk about in technical space, but my view is that if somebody else forges a path forward, I think that's going to be a positive influence.
I think she essentially covered everything. I think one big impact of, let's say, success of the Finnish case would be that in the UK we have to engage with the communities, and that's the process. We have a community sitting, and then we have to convince them of hosting a geological disposal facility. Now we don't have a site, and the success story of Finland will serve as an example when we engage with these communities as to there is a case and that has been, you know, done successfully. But then also, although we say we will have a repository, but it's going to take a lot of technological development. We may have some technology at the moment, we may not have some, and we have to buy technology from possibly oil and gas industry, you know, for underground tunnels and those kind of things, because it's going to be a very complex structure on its own. And we can learn a lot in terms of what they have done and what they have done good and what they have done bad. And that is going to affect our strategy going forward as to what site we choose. That might affect that. Let's say if it goes successfully there, then that might encourage us to follow a very similar approach. Although, as she said, our wastes are a lot more complex and we necessarily don't have the same, you know, geology. But it will certainly have, I think, a positive impact if they are successfully doing it.
Thank you. Anyone else? Any final comments for that question?
Yeah, I think it's just important that we do take benefit from the progress of the international scene. Just need to accept that UK laws and regulations may differ, so we can take credit, but we need to be a bit mindful of some subtleties, perhaps. I think also, it was touched on before, the inventories can be very different country to country. So because it's been, you know, it's progressing well within one country, that doesn't mean that in our case there isn't a lot of work still to be done. And then in a volunteer-based siting program, which is what we have in the UK, it's got to be consent-based with the community. In some senses, we have a waste, and we will be offered some geology from that local community, and that may differ markedly from the international precedents as well. So again, it's the case that learn from experience where useful, but we may also have to do a significant amount of additional research to understand how our waste in a UK GDF in certain geological settings could perform, and it could be quite a long learning curve. So we, you know, I think we can learn and take credit or take comfort from overseas successes, but don't lose sight of the significance of the challenge in front of us. Thanks.
One comment for this, because when I found out this voluntary approach, I was very surprised, because I think it's quite unique. compared to other countries, because I know, for example, in Hungary, the site of the geological disposal facility was first determined based on the geology. So they tried to find the most suitable geological conditions. I found it really a bit weird for the UK to first ask for the community support, and then we will be offered with some kind of geology. I don't know if it's correct, or how do you see it?
I think we've had a journey to get to where we're at, really. Yeah, there's some history there. So, I mean, the Finnish case that our questioner raised is a volunteerism. So the ones that are at the forefront tend towards being a volunteer community. The challenge is if you choose a rock and your local community doesn't agree with you, then you end up with conflict.
Yeah, I know in Hungary there was one where it was pretty difficult to find suitable geology. So if the UK, I don't know the geology of UK, but there are several opportunities. It shouldn't be a big problem.
And also it also explains you not having a geological site already identified, so we don't know exactly what type of geology we'll be dealing with. That means our research program has to be much broader, because we have to address different types of geologies. We can't just focus on one geology because we don't know what that geology is going to be. And this is where also the scientific challenges lie, that you have to have a much broader research program than, let's say, Finland might have, because of our own complexities.
And you also have to tackle the social science aspect of a volunteerism system at the same time as doing all the whizzy techie stuff.
Yeah. But not necessarily. I think the community engagement is important, and opposition is not necessarily bad at times, and it can bring very positive changes sometimes in the industry. Of course, we have to engage and give the evidence-based research. There's a history of I don't know if you know about dumping nuclear waste in the sea. I mean, there's a history in the UK, in Sweden, and we know the government, at the time in the 80s were hiding all the facts, and then it came to light, and no one is today crazy enough to do that kind of stuff, and it's much more accepted in the community that it's a lot more beneficial to be open and explain to the public, and if you do that enough, people will understand it, hopefully, but that's the approach we have to take.
Thank you very much. We've got a couple questions in the chat. So the first one is on the skills questions. Do you think that there is a comprehensive view of the skills gap that the UK is facing in the nuclear area? Yeah, go for it, Rick.
Comprehensive, no. I don't think there is a comprehensive understanding of that challenge. I think as an industry, we regularly identify areas where we are facing very immediate shortages in certain skill sets, and there are some areas where we know that we've got a limited number of people we can sort of classify as subject matter experts in those areas, and we're making concerted effort to bolster the number of people that we've got that can contribute to those skills areas. I think, though, if we look at the sort of wider supply chain and all of the sort of engineering firms and the contracted firms that we bring in to help us deal with some of the challenges that we have across the NDA estate and the wider industry, we don't have a comprehensive measure of where they might be facing shortages and where they might be finding it difficult to recruit for certain areas. A lot of the skills that we need as well to support the mission aren't necessarily nuclear specific skills. We're going to need people who know about robotics and artificial intelligence. We're going to need people who know about how to do sort of long-term financial planning and integrating that with risk assessment. We're going to need more social scientists working in this area. And I think there's a lot of things that we're going to need to do as an industry in the next 20 to 30 years that we don't even know that there's a skills gap there at the moment. We haven't even identified that. So yeah, I think there's still challenges that we're working on in that area.
No, thank you, Rick. Anyone else any comments on that, or should we move on to the next question?
Yeah, maybe I would just add, I think in terms of, okay, what Rick mentioned in terms of the challenges, but I think also one of the challenges is, for example, me there's a big difference between someone having worked in industry for 20, 30 years and having that industrial context of the final goal. And then someone as a PhD, for example, himself starting or myself in a very early career stage. And how do we sort of develop a culture that a student or an early career researcher has that industrial concept and not just entirely relies on the fundamental science only, which is key. We have to sort of do the fundamental science, but we have to have the broader context as well. And we have to develop that set of link to introduce the PhD student to the ideas of what the final goal is and give essential, at least the basic knowledge of how the whole system needs an integration, and we need to work as one unit to address the challenge.
Maybe I could, with some bias, speak about something that Nuclear Waste Services has done over the last 3 or 4 years to think about that question. So I think Rick described an industrial kind of skills area. Yeah, I think everyone acknowledges there are opportunities to develop our trained people. And Nuclear Waste Services several years ago thought about this and decided to create something called the Nuclear Waste Services Research Support Office, which is primarily an entity that is an umbrella to encompass a whole host of academic discipline, PhD students, fellows, etc., etc. And the aim of the Research Support Office is to develop that community so that you do end up sitting in a room with a microbiologist, a social scientist, and an engineer going about the problem. So, and that is a unique endeavour in Europe. I am biased because I am the academic lead for the Research Support Office, but I think some of this innovative way of thinking hopefully will reap its rewards if we do it right.
Yeah, maybe I will give an example, possibly an irrelevant example in this case. I think a few years ago we were having a meeting in Japan, and in that meeting there were different scientists from the UK, and the idea was to develop. It was a UK-Japan sort of collaborative event. And I was talking to one of the persons in that group from the UK side, and I was asking him, what is it you do? And he was saying that he works in yogurt industry, right? And so I'm surprised, how does someone working in yogurt industry come in the nuclear sector in the UK? What's the link here? And then he started explaining me that when they make the yogurt and it sticks to the pipes, right? You make the yogurt flow from one end of, okay, and on an industrial scale, we don't, it's the yogurt, okay, it flows through the pipes and everything, and then at the end, some of it sticks to the walls, and then you have to clean all the pipes before you start the next batch of yogurt. And there's a lot of research on that. Okay, how do you remove the sticky yogurt from the pipes? And they flow, for example, ice at certain temperature and everything. And then, in Japan, they have, because there was the Fukushima accident, and then there's a piping going underground, which keeps the site cool, so everything is confined. So there was a relevance from someone coming from a yogurt industry as to how to clean the pipes of yogurt in the nuclear sector. And this is the kind of links we have to find and develop. There is relevance of the research happening in oil and gas industry, in, for example, yogurt industry. I don't know what that is, but we have to bring all the people together to address these challenges, and this must be the approach going forward.
Yeah, no, thank you. That's quite a nice analogy. Next question is, for the public acceptance in the UK, how many percentage of the public agreed with the implementation of the GDF currently? And for the overall percentage, how percentage that the public acceptance has in the overall portion of the project implementation?
Sorry, could you?
Yeah,
sorry.
I'll start with the first question. For the public acceptance in the UK, how many percentage of the public agreed with the implementation of a GDF currently? So
depends who you ask.
Yeah.
So if we take this as a general kind of public acceptance question, depends who you ask and to whom you ask that question, I think.
Yeah. Yeah.
So I think net zero has moved nuclear to a more positive environment, nuclear power, future nuclear. I don't know the numbers for radioactive waste disposal or nuclear dumps, as they're often referred to in the press. There was something in 2016 that did that, but I don't know what it's like more recently.
I don't remember exact numbers in the UK. I remember a few years ago there was a survey in the US. I think the survey was, explaining the nuclear sector in general and the waste management to the people and taking their opinion before and after and to see what the perceptions were. And I think in that survey, I don't remember exact figures, so don't quote me on that. I think it was 50 plus who agreed with the idea. And then, okay, you have then mild agreement to strong agreement to strong disagreement. But I would say probably 50 plus people would be in principle okay. But it's always those 5 or 10% who are very vocal about something that can create an issue, and you have to possibly, not everyone may agree with it, but if everyone sort of mildly says, okay, let's do it, okay, that would do probably for the community.
Maybe Simon could speak a little bit.
Oh,
about
yeah, I
this.
mean, there are a couple of ways of interpreting the question. Deep geological disposal is government policy that was arrived at on the basis of various scientific endeavours over the years. For the Committee on Radioactive Waste Management, for example, did look at the options over a decade ago. That was the preferred option that was derived, and that's the sort of now the basis of government policy for higher activity waste. You could also interpret the question about community hosting a geological disposal facility, which is, it's a long way off. We're at the community partnership stage at the minute in 3 communities, and we have a working group in another community. At some point, not ascertained to the best of my knowledge, the local community will have a say on whether or not they want to go ahead as hosts for the GDF, and that will be on the basis of a vote. The format, not sure. I don't think it's been decided yet. To be worked out as part of the ongoing process within any one community. But there will be at some point a public vote on whether or not community wishes to essentially remain in the GDF siting process.
Brilliant, thank you. We've got one more question in the chat, and then we'll see if there's anything else floating around. What would the UK GDF host? Both reprocessed casks of vitrified high-level waste and spent fuels from direct disposal. Would you actually, let's start there, and then we'll do the second part of the question. So what's it hosting?
Currently, the idea is the GDF will host high-level waste, spent fuel, plutonium altogether. It's a one GDF for these 3 different categories. There are ideas around as to whether the GDFs could be tailored towards specific waste, but it will be at the moment it's an integrated sort of approach.
So the current policy is that we have intermediate level waste and high level waste, and high level waste is spent nuclear fuel, and it also includes some vitrified waste. The GDF will accept those components, and plutonium isn't currently classified as waste in the UK. So it will be taking vitrified high-level waste. It will be taking some spent nuclear fuel to be determined by the future programmes and reprocessing, and it will also take intermediate level waste. Referring back to what Simon said earlier, the idea is to minimise the amount of intermediate level waste that has to go to deep geological disposal, and that we're looking at optioneering for example, near surface disposal. But you're going to have cementitious intermediate level waste in one area, and you're going to have spent nuclear fuel and high level waste in another area.
Yeah. So adding the second part of the question onto there, I think it's a nice lead into it, is would you reconsider spent fuels or depleted uranium for future reprocessing and recycle use in fast reactors?
Not government policy at the moment.
Yeah, but it certainly has a commercial value. Even if we may not use it here in the UK, we had to think about whether, because we had to think about how the nuclear sector is changing around the world, in Asia, in Middle East, and the countries who didn't have nuclear power are now probably going for it. And so it has a huge commercial value. So it's not, as she said, the uranium, plutonium, these are not classified as waste at the moment because of maybe future use in the UK or because of their commercial value. So we don't know how things will go in the future.
I think as well, just sort of going back to something that Kath said there, we don't consider necessarily all of our inventory as waste at the moment. So, you know, we're still considering what the different options might be for plutonium, for example, for potential reuse in the future. We have to bear in mind that any of those decisions would have to be underpinned by, you know, a suitable reactor to burn that material in. You know, if that was the option that was finally selected, but that decision won't be taken by us or the industry. That would be a decision for the government.
That's right.
Just to add on the plutonium side, as the plutonium is not waste, but I think what we understand in the community is at least 5% of the plutonium inventory. So it's stored in, let's say, PVC. What are called drums, and about 5% of that will be contaminated to the extent that it probably doesn't have a use in Marx fuel fabrication, and at least that 5% of the plutonium inventory will need to go as a waste.
I think that leads quite nicely into this next question that's popped up. Oh, they're all coming in now. Picking up on Simon's intro, also what we've just been talking about actually is, do you think we as a country should be doing more to recover or recycle specific radionuclides from waste in order to reuse them for radiopharmaceuticals or other applications?
I think that option should be looked at and looked at very seriously. You do need to think about a closed loop process. So if you want to extract X from Y, you don't want to create so much waste, so much more waste that you might have solved one problem but created 10 new ones. So you've got to think about it holistically. It's certainly an issue that is on the table and needs to be thought about seriously, but do think about the whole process you're going through. So if the aim is to extract radionuclide X from material Y, that's fine. What are you going to do with all the stuff you create en route, the leftovers, the industrial units you create, which will presumably become contaminated? And it's having the being able to step back at the outset of such an endeavour and asking yourself, is this economic? Is it safe? Does it get me to a better place, or am I just creating a lot of additional trouble that someone else will have to deal with down the line? So it's not off the table, but just go in with an open, with your eyes wide open.
Thank you. Any questions from the audience? Otherwise, we do have one more in the chat as well. How much waste is going to be disposed in a GDF, and how many GDFs will be required for 300 years waste at least? What are the unforeseen environmental impacts that these will have, and will there be enough space for an infinite nuclear waste disposal? That is the ultimate future nuclear waste question. Anyone?
It's a bit big, isn't it? What was the first bit?
The first part was how much waste is planned to be disposed
What
in a
unit
GDF?
would you like? The Albert Hall is typically the unit of preference. I think it used to be 2 or 3 Albert Halls worth, I think.
So I think it's 3/4 the volume of Wembley or something at the minute.
There you go. It's a Wembley unit these days. So there was a double-decker bus unit as well. So for vitrified high-level waste, there are 15 to 20 double-decker buses worth of that volume in the UK. The intermediate level waste is a large volume.
It's about.
Sorry, Simon. I think it's also worth pointing out there is a a public website that anyone can go and visit, the radioactive waste inventory website. If you Google that, it will take you to a page which has all of the most recent data in terms of volumes of waste that we've got in our current inventory in the UK. So I think it's fairly straightforward. If you go to that site, you can find the actual numbers.
300,000 waste packages in the most recent inventory to dispose of in a small town subsurface.
And it is high level plus intermediate, 300,000. Yeah. I remember just figures, I think 94% of our waste is about low level. Then we have roughly about 6% intermediate level, and the high level waste is 0.03%. It's a very small fraction of the waste. And we are talking roughly about 6,000 canisters.
By volume then? By volume?
By volume,
yeah.
Yes,
by activity,
yeah.
it's all skewed in the...
Yeah, the activity is, high level waste is the highest activity, and then, okay, we go down from there.
So touching on a second part of that question, I'll just pick a bit because we're running a little bit low on time, is what or are there any unforeseen environmental impacts of a GDF?
I think I will let Katie probably start with that.
I think unforeseen, no. I think there's a really robust history and way of thinking about this to develop something called a safety case. And I was reflecting on Simon's answer to the whole fuel cycle, to the whole cycle system. With nuclear, we've got decades and decades and decades of taking responsibility for all of the waste that comes out and understanding it and storing it and developing planning to deal with it. And can compare and contrast that with hydrocarbon industry. Let's put that one into the room as well, because nuclear is different, but it's not that different. And in some ways, it's different because it thinks about the way that this whole process will be developed to ensure minimal risk in the future.
Yeah, I think in terms of unforeseen, we don't know because it's unforeseen, but one of the things I think that we do need to pay a little bit more attention to is the impact of global warming in general. Although in the UK, the case is it won't have an impact on our ideas about geological disposal, but we know that in the next 100 years, the water level will rise by about 1 meter predicted in the UK. And that means some of the southern parts of Cumbria will be under water. There are ideas about, okay, we will have a protective line that water won't come. But when we talk about nuclear waste management, we are talking about hundreds of thousands of years. And then we have to consider these environmental impacts, especially in the regions which are more prone to getting submerged because of the global warming. We don't know what the extent of that will be over the million years. But because we haven't done, let's say, high-level waste disposal yet, so I think we can plan for impacts like these. But in the UK, the case is it won't have a big impact, probably.
I think we've got time for one more question, which has popped in here. So another question is as to whether or not the tunnels hosting the high-level waste and spent fuel will be buried or not. If we bury those wastes, it'll be difficult to extract and reuse them for future reusal. What do we think? And should we consider something like open tunnels?
It's the GDF's intended to be a disposal facility. So it's going to, waste will be emplaced without it having an intention of retrieving it. And if the government policy may change, but at the minute it's a disposal facility.
The French programme has retrievability into it. We're not that far down in the UK programme. But yes, Simon is currently correct. It's disposal. Yeah.
So it's permanent disposal?
It's disposal.
Without any retrievability?
That's how it currently is, but that will evolve in the community.
Mm-hmm.
Presumptively, we'll have a view on that.
Mm-hmm. So, but nonetheless, I think the tunnels, even if we say geological disposal, once you start putting the waste in, it's not going to happen in a year or 6 months' time. it will take years and years, and during all that time, the tunnels will the accessibility has to be there.
Rick
So-
gave the depressing fact that
Yeah.
we'd all not be here by the time,
Yeah, by the time, yeah.
time it closes.
So-
Although it's a job for life.
Mhm.
No, brilliant, thank you. I think we, unless there's any final questions come in, we might wrap it up there. There's some thank yous coming in the chat, which is really great. Yeah, huge thank you to all of our panelists, both in person and obviously on Zoom. If everyone can give us a nice round of applause for the panelists. Thank you all so much for your time and your knowledge, and obviously answering some quite tough and very challenging questions as well. So huge thank you. And yeah, I think this will be available as a recording on YouTube, and we might be able to send it out as a Zoom recording as well. And thank you everyone for coming along as well. Thank you.
Thank you.
Thank you very much, guys.
So.